that because who once said mathematics is the field of sciences and number theory is the field of mathematics. With this profound insight in mind, it is my distinct honor and privilege to extend a warm welcome to each and every one who gathered here today at the second symposium on recent trends in mathematics, statistics, and engineering. The symposium stands as a testimony to our collective dedication to the pursuit of knowledge and innovations in these critical fields. Reflecting on our journey, it is worth noting that our previous symposium was held amidst the challenges posed by the COVID-19 pandemic. Despite the adversity, our commitment to advancing knowledge remains unwavering. As we gather here today, let us remember the importance of fostering a spirit of inclusivity, diversity, and collaboration among our communities. By embracing different perspectives and experiences, we enrich our collective understanding and propel our fields towards new frontiers of knowledge and innovation. Now, I'd like to invite our academic president, Dr. Sunitha, to share a few words with us.
Good morning, everybody. Wonderful to be here. The second symposium on recent trends, mathematics, statistics, and engineering. This particular year's theme, I don't know whether they have a theme, but I can see that there is an underlying thread in the workshops that are organized. The experts will be talking about use of analytics as a subset of mathematics. Perceive this. This is a part of a series of activities that we have undertaken in MAHE to make sure that our students and our institution is right at the edge of the cutting edge technologies that are happening around the world. Our students and the institution itself is at the forefront. That is how you can see that. In fact, we are advancing far ahead than most of the institutions here in terms of fintech, in terms of analytics, in terms of robotics, and all these cutting edge technologies. Because we want our students to go out in the industry to make a difference. And for us, use of analytics and mathematics and statistics is not just to analyze business data. These workshops, the workshops today also will demonstrate to you the use of analytics in other fields, let's say fluid mechanics, and so many other fields also use this. And then we want to make sure that our students understand the use of analytics, analysis of the numbers using mathematical, statistical, analytical tools in a variety of contexts, not just, let's say, marketing or sales data. There's a lot of feeling always that happens that, okay, analytics is about sales data, marketing data. So, no, it is not just that. There are many engineering problems today that are being solved in analytics. There are many biological data that is being analyzed to find problem. The prescriptive analytics techniques that are coming up in the field of medicine, analytics is everywhere. And then we want our students in all the schools to be using technology to do whatever they. So gone are the days when you were restricted to your own field. Technology is about to be used in your field, and therefore you are good in your own field. But at the same time, you must be a great mechanical engineer, but at the same time, you should know how to use analytics. That is the underlying theme of what we are doing at MAHE. And this, I congratulate the organizers of this, the chairperson, the deputy chairperson, Rasha, Rajesh, for organizing this important workshop. I wish all the participants very best in all these workshops. And then, of course, I would like to thank Dr. Varun for being here at the all the best to him.
Thank you, Dr. Sudhindra. Now, I'd like to invite Ms. Asha to welcome the keynote.
I'm deeply honored and privileged to extend a warm welcome to our esteemed guests and dignitaries present in today's session of the second Symposium of Recent Trends in Mathematics, Statistics, and Engineering. Mathematics serves as the backbone of data analytics, engineering, and various other fields, providing the foundational framework for problem solving and decision making. Its versatile applications enable precise modeling, analysis, and optimization, driving innovation in diverse domains. From School of Engineering and IT, this event marks a new beginning. It's an absolute pleasure to have with us the academic president, Dr. Sudhindra, the CEO, Mr. Niranjan, the Dean of STEM program and Chairperson of School of Engineering and IT, Dr. S.K. Pandey, Deputy Chairperson, Dr. Rajesh Sargam, and the teachers from various schools and program directors and all my colleagues. Your presence here today underscores the significance of our symposium, and we are truly grateful for your support and participation. Furthermore, we are thrilled to welcome our distinguished keynote speakers, Dr. Varun, Professor, Associate Dean, LP University, India, and Dr. Tamim Basha, Department of Mathematical Sciences, Ulsan, National Institute of Science and Technology, Republic of Korea. It is with great enthusiasm that we introduce Dr. Varun, our esteemed keynote speaker for today's symposium and hands-on work. With over 17 years of experience in university admissions and teaching to both undergraduate and graduate students, Dr. Varun has honed his expertise in leveraging data science and analytics to drive decision-making process and enhance customer experience. As a professor and associate dean, Dr. Varun is deeply passionate about integrating analytics into decision-making across various domains. He has successfully led large teams, including a university admission contact center with over 400 counselors and spearheaded outreach admission operations with a motivated team of 80 counselors. Dr. Varun's educational background includes PhD in theory of elasticity alongside clearing the prestigious SIR NET NET examination in mathematics. His role as the head of the department in the School of Computer Science Engineering has provided him with invaluable insights into the applications of mathematics. His dedication is evident in his contributions to the academic community through his research publications. Beyond his professional endeavors, Dr. Varun is committed to sharing his passion for data analytics through teaching Python, advanced level Excel, and managing a YouTube channel dedicated to these subjects. We are honored to have Dr. Varun with us today, and we look forward to his insightful address on the integration of mathematics, data analytics, and engineering. Please join us in extending a warm welcome to Dr. Varun, as we commence the enlightening symposium.
Hi, good morning, everyone. Good morning. Thank you so much, Dr. Asha, for the warm welcome. First and foremost, I'm expressing my deepest gratitude to the organizers for inviting and offering me the opportunity to extend my passion, my knowledge, and my learnings on in the field of data science, data analytics. Today's theme of data analytics has totally revolutionized how we see data today, how we interpret data, how it helps in decision making, and how it helps in predicting future trends. In today's session, we'll not only focus on understanding the importance of data, but we will also introduce you to the tools and technologies which can help you get started in this particular area. I have divided this session into two parts. In first half, we'll be focusing on the robust capabilities of Microsoft Excel, which is one of the most popular spreadsheet tool, and almost you will find everywhere if you go, there are people who have different skill level associated with Excel. And in the second half, we'll try to build the similar reports by using Python with the help of artificial intelligence, or most popularly known as ChatGPT. Though it is actually unjustified to cover this entire topic in a session of 2 hours, 2 hours, 30 minutes, but I'll try my level best to deliver whatever maximum we can do in this particular session. So, people use Excel for preparing daily reports. Whenever any report is to be prepared, generally people write formula. If different sheets are to be combined, people write X lookup, V lookup, find, match, index. And next time they again need to prepare a similar report, they again have to do the entire stuff once again. So with practice, the time may come down a little bit, but not less than 50%. But I have found after in 17, 18 years, still people know very less about the data handling capabilities of Microsoft Excel, which is theme for our today's particular session. This particular scene contains how Excel can be connected with different data sets, right? And we can leverage its Power Query or connections setting, where we can record our steps. People use macros also, but it is more sophisticated way of preparing reports, where once you record your steps of preparing a report, next time you just replace the underlying data and your report gets refreshed. And it doesn't take more than 1 minute. Particularly, I have also means you might be aware, I take care of a big team, and we do a lot of analysis on daily basis. There are certain reports which earlier used to take 1 day or 2 days to prepare because we had to deal with millions of records to prepare a report. But now, with the help of these tools and technologies, what was actually being done in 1 or 2 days, we are able to do it in matter of few minutes. So I'll try to introduce you to that part of Excel. So in second half, we will try to prepare similar report by using Python and ChatGPT. ChatGPT, many of you might be using for different purposes, right? One of the things which it has done is has cut down the learning time. Earlier, if you had to learn one particular tool or technology, you had to spend time in a library, read different books, go through different videos, material. But now people can talk about prompt engineering also, but I guess this chat GPT is responding even to natural queries also, which we are be writing in today's session also. So in case you are familiar with chat GPT and you understand some fundamentals of programming, you can code like a pro, right? Someone who has let's say experience of 10, 15 years just in a matter of few weeks. Sure. We can start coding like that. So in second half we'll cover that, and to give you a glimpse of what we need to do, I have undertaken a data set which I'll be sharing a link where from where you can download this data set so that together we can work on the same report step by step. I have taken a data set from an online source of a US university's admission data, right? And that data set contains more than 1 million record. So it is a large data set which we need to work on today. And let me, so that context is clear, that particular US university's admission data set, we need to understand about the university's working model so that we can correlate with what kind of report we are preparing. The idea is to learn tool and technology and also have the domain knowledge of what kind of report or for what purpose that report is being prepared. Having domain knowledge is one of the key aspects of data analytics. unless you have some idea about how data has been collected, what that each single record or column means, it actually you won't be able to generate a meaningful report. You may come up with certain graphs and tables, but that may not bring something useful unless we have deeper understanding of that particular data set, how it has been collected, what each record means, right? So let's have first understanding of what that US university's admission data set is. That the particular US university's data set, US university, private university, which solely relies on funds through students' tuition fees. And for that university to survive, it is very, very important to optimize its admission process so that it can attract more number of students and increase its revenue. To give you more context, so that you feel more connected to the data, we will all of us will assume that we are admission head or dean admission of that university, right? And then we will work on certain data to get certain to answer certain questions. I'll pose certain questions in this particular session, which we'll be trying to answer through our data analytics tools. That university's admission process, I'll show you what the data set we have. And before that, let me tell you that university's admission process is a three-stage process where first it collects leads. Leads you are all, I guess we all understand leads and inquiries, right? Lot of students inquire on that university's website through email, through chat, through calls, and submit their inquiries. They want to know about the different programs, eligibility, fees, scholarships, and everything. University has those leads, and university also publishes its information on different partners or publishers who also help university in collecting leads. And then also university uses digital marketing to advertise and collect leads. So different sources of leads. Second step is once those leads are received, universities counselors they interact with those leads on call, chat, email, whatever way students prefer, and then interested students submit applications. Once applications are submitted, students they write entrance exam for that program. They go appear to interview, and then shortlisted successful candidates are allowed to take admission. And once student finally pays admission fees, they are admitted into the program. So once we have clarity about the process, now let's have look at the data set which we need to work upon in today's session. The link also from where we can download. But let's have a quick look at what files we have. We have a leads file, which contains more than 1 million leads. This lead file contains uh, 4 columns. Entry date means when the form was submitted, lead was submitted. Each lead is assigned a unique ID, right? Lead ID. And then from what source that lead has been collected, source is also mentioned. And in case any counselor has worked upon that lead, what status he has assigned it to that lead means interested, not interested, no response, irrelevant. And then it is always done. So counselor may assign different lead status to all these leads, but for future understanding, those statuses are bucketed into some categories. So leads have been there is a separate file which contains logic where different lead status can be categorized into uh, cold, warm, and hot dead leads. Means leads which have more chances of taking admission as per council, they are categorized into hot leads. And then the second stage of the funnel admission data, we have in today's data set, we have more than 16,000 rows where those rows contain this kind of data set where application level is mentioned, PG or PG, UG, fellowship program, a unique application number, application payment status. I told you that there is three-stage process: lead, application, and admission. So application payment has been done or not done. If you see, it contains some application approved, sorry, payment approved, and then payment success also. Method of payment. Then, in case some of the students who have successfully taken admission also, admission payment date is also mentioned. Entrance payment date we also have, and then province from where that application has been received, and how this file is connected with the previous file read by through this column. Each applicant throughout its journey has single unique ID, which is lead ID. Starting from the first step, lead ID is assigned and it remains associated with the applicant during application process also and admission process also. So this is how we will be connecting to different files through this column lead ID. And then we also have a file which contains expenditure incurred by the university over the period of time on those sources, so that we can understand where university is spending and then take certain decisions to optimize the process. Finally, these sources from where leads are being received, they are categorized also in a new file where what are the publisher, paid marketing, and then organic leads which come through website, chat, email. So there is this file which contains these source category also. So before we jump into the data, we have two questions which we need to answer after this workshop. The first question is, what is the most reliable source of admission? Is you might have looked at the previous screenshots where we had sources of leads. So what is the most reliable source of admission where we should focus on? Because all of us are now acting as dean admission of that university, we need to answer certain questions. And the second question which we need to answer in today's session is, which source is the most cost effective for acquiring admissions? So these two different questions we need to answer. One, which source has the most reliable source of admission? And the second one is, which is the most cost effective? Because I told you the university which we are dealing with is a private university. It is not a public university where funds are paid by the government. University has to sustain itself through students' funds, right? So these two questions we need to answer after this workshop session. And once we go through this hands-on session, we'll prepare certain analytics similar to I'm showing certain screenshots, which will help you in understanding how to answer these two questions. The best part is we will prepare a model where once a model is ready, if you want to prepare a report once again, data, let's say today you downloaded data and it contains 3 months data. After 1 month, you again want to prepare a report, but now data set contains more than 3 months data. You just need to replace the original files and just click on refresh button. Your report, similar report will be ready. You do not need to spend the entire time once again preparing the same report, right? So let's begin our journey into the today's session. I'll request you to click on this link, type this link, and download the dataset which we need to work in this session. So link I have mentioned here, Gately MAHE Dubai 2024. I request you to type, and in case you are accompanied by some of your colleagues, in case you do not have laptop, request you to check with them so that all of us can have understanding of step-by-step process. So let me know in case you are able to download data from this link once we have downloaded the data. So I have shared the link on chat also, for those who have joined the online session. Once you have downloaded the raw data folder, zipped folder, click extract all. So extract all files in case you have downloaded the zipped raw data folder. Make sure you have all these 5 files which I demonstrated that presentation also. It contains application, expenditure, lead bucketing logic, leads, and publisher category. So now what we need to do, because we want to create an Excel model, we need to open a blank Excel file wherever you have installed, or if you want to start a new Excel file in the same folder, just right click it and click on Microsoft Excel. So start a blank file, Excel blank file, and let's learn how to import that data set into Excel to prepare a model. So open a blank Excel file. I guess you seem to be ready with that blank Excel file. Is that so? Right? So now, if you look at the tabs which are available above in the first row, home, insert, you might have one tab, data. Right? Click on that data tab, and then there is an option from what sources you want to get data. So I'm clicking once again data, and then once you click on this particular data, then there is an option get data from file. So it supports numerous sources of pulling data into the data model. Popular ones are listed on the top from another Excel file, from CSV, from XML, from JSON, PDF. All these things, entire folder can be pulled in, but we will pull files one by one, right? So click on this because our data set is in CSV format, contains Excel has otherwise by default certain limitations depending upon which version of Excel you are using. There is some limit on how many rows it can contain. But now, once we have data in CSV format, we can have as much data as you wish, billions of rows. So click on CSV and then navigate to where you have kept your raw folder. Right, wherever in downloads or whichever part, or in case you have extracted to the desktop, wherever you have kept it, click on that section and first let's import leads. Shall I repeat it? So once again, I'm going back to this default blank Excel file. Click on data, then click on get data, and then finally there is an option from file, text or CSV. Click on that CSV, and then wherever you have kept that folder after extracting the files, go to that folder and click on leads. This file first we need to import. And at the bottom we have an option to import, and Excel will start importing that entire data set into its model. So you will see a screen like this, right? It automatically identifies, and then at the bottom we have three options: load, transformation, cancel. Click on transform data. Power query editor will open up. So I want you to be familiar with this particular interface. If you are, it is first time you are using this particular uh, tool for preparing an Excel report. So now, in the left side, in the left panel, if you see, it shows you the file with which it is connected. In the middle panel, it is showing you all the columns or data set which it has put in right now. And on the right side, query settings. You see it is recording all the steps which we are going to perform. And it is a kind of time machine query settings panel. We can reverse the process also. Let's say you go through certain process, you once the report is prepared, you feel like this step didn't went right. You can come to query setting mode and re-edit the query or cancel that particular step, and remaining steps will still be performed. So source, change, promoted headers, these three steps are recorded. Now in this particular data set, let's say if there is any error or you want to replace certain values, it can be done. right here, and all the steps will be recorded. Next time, when we want to prepare a report, Excel will automatically perform all these steps. Won't be any requirement to repeat the step, repeat these steps. So for the time being, because our Excel file is CSV file is formatted, I do not need to perform in on this particular data set. Also, in the middle pane, if you look at the top where these headers are mentioned, entry date, there is a symbol of calendar. Excel automatically identifies this particular column is a date column, right? And lead ID, you see it contains on the left side 1, 2, 3. Means it is automatically identifying this particular column is a number, right? This lead source contains ABC, it is a text, and again lead status is again text. So we are okay with this. Now we want to pull in the remaining files. Again, either we can go back close this particular module here and again repeat the process, or in case it is already open, here on the top right corner there is an option new source. You can click and import one by one remaining files. So let's import remaining files, same interface, CSV. Either we can close it and again pull the data set right from the Excel file, but if you want to pull files from this particular interface, you can pull from this particular interface also. So I'm going to pull the remaining CSV files. We have 5 files. So I have pulled in leads. Now I'm going to pull applications. Same data set, click on OK. And now in the left pane, you will see there are 2 sources, leads and applications. Left pane contains 2 sources, leads and applications. Let's pull the remaining sources, file. Then let's pull expenditure. If you need help on any particular step, let me know. Raise your hand. Try to extend whatever support possible. Then find last 2 files, lead bucketing logic. Let's import them also in the dataset. I need your attention for a minute here on screen. Now, if you look at this particular file which we have imported, its headers contain column 1 and column 2, contrary to what we expected, lead status and status category. Right? For other files, their headers were successfully loaded, but now it doesn't contain the headers which we want. So I want you to be familiar with this interface now. It contains the home tab contains certain useful options. One of the options, if you see in the middle, is use first row as a header. So by default, due to some reason, this module could not identify the header row. So we need to tell it by clicking on this particular option, use first row as a header. So means first row doesn't contain any data, it is containing only headers. So now, if you see, the steps are being recorded, promoted headers. So it looks now okay. Now let's import the last file which we have from file. And last one is publisher category. The sources from where we are getting the leads. And again, it seems like there is same problem, column 1, column 2 instead of headers. So we need to repeat the same process here also. So this particular file again doesn't contain the suitable headers. We again need to click on use first row as headers. Up to this step, if we are ready, now we are ready to start moving in the direction of making a report. We have successfully loaded the raw files into our data model. Shall we? Shall we move to the next step? Are you with me up to this step now? Raise your hand in case you have done up to this step. All right, thank you so much. So now let me make you more familiar with this particular Excel interface. I told you on query side left pane, we can still have a glimpse of what kind of data has been loaded into. If you want to navigate, we can navigate. How many of you know about VLOOKUP? Raise your hand in case you know about what is VLOOKUP in Excel. Nobody? If let's say I look at this leads data set, it contains a lead ID. This is column lead ID. And our applications data set also contains a lead ID. What I want is now I want to see which leads have successfully crossed the second stage. They have means reached up to application stage, and then finally I want to see which leads have reached up to the admission stage. So how do I connect both data sets over one single common column, which is the lead ID? I told you at the beginning we need to understand the underlying process also that each lead has a unique ID, which is mentioned here in this column, lead ID. In applications, this lead ID is same, which is available here in this data set also. So let's connect these two data sets by using connections. How to do that? I need your attention for a minute again on screen. Where you clicked on use first row as header, on its right on the top there is an option merge queries. I'll teach you different ways to connect files. There is an option merge queries. If you click on it, so now it's showing me an interface which contains two tables. I want to connect this particular leads with on this column with another data set. Let's say first I want to connect it with applications, and the common column I'm telling it after scrolling, it is available here on last. So I'm clicking on lead ID. Means by default leads is selected. Second table I have selected from this interface applications, and then I have selected the column. The common column is lead ID. Those who are computer science students or those who have some familiarity with programming, they I guess or databases, they might be knowing meaning of left join, inner join, right? By default, it is going to join two tables by using the logic of left join. You understand meaning of left join? Those who don't understand, left join is it will keep all the records of the left table, and from right table it will just match, select the matching records. So our left table or first table is leads. It will this particular combination will keep all the leads which are on the left side, but whichever lead IDs it can find in applications, it will pull those applications into this particular table by joining them on left, right? If due to any particular reason you want to change this setting, right, you want intersection part only, which is common in both, then you can use inner join. But for my purposes, left join is suitable, so I'll stick with default option and click on OK. Fine, done. We need to be little quick now because we need to repeat this step several times with other other 4-5 files. But before you jump into, if you look at now, our this data model leads contains one column application. I want this kind of report to begin with. What was the first question? Which is the most reliable source of admission? So now we have pulled in lead source also. I want to see source wise how many leads we have, how many admissions have been converted out of those leads. So what do you think shall be done in this now? In case you actually need to prepare a report manually, what will you do? What will be your next step after this? Yeah, it can be graphical representation by this kind of bar chart. Higher bar chart will obviously show more number of admissions. But because the scale is different, so what we will do is we will try to make the scale uniform by converting it into a percentage kind of thing. One source, let's say, has 1000 admissions, another source has 10 admissions. May give you false impression because the second source may have given you 10 admissions out of 15 leads, but the first source may have given you out 1000 admissions from 5 lakh leads. So, which is more important for me? I need to put in less effort from the second source. So, we need to make the scale uniform by converting it into some sort of means percentage is the best way statistically to convert it into a uniform scale. So how we can convert it into a percentage? Any idea? So what we need to do? We need to count leads. We need to count admissions. So count of admissions divided by count of leads into 100 will give us percentage of leads converted into admissions, right? So how do we count now? Look at our data set now. Let's see how do we count this. So for counting leads, we can count these lead IDs, unique lead IDs. That will give us an idea. Lead source, uh, these are lead sources, but we have now a broader term which is lead source category. So publisher category, that will be helpful. Now, but for admissions, what do we have? How to identify which admission has taken place in this data set? So the column here is admission payment date. Admission payment date, I could not find any other column in this, but there is one column available. Admission payment date. So I want to in Excel, there are tools available for summing, for counting. So what we want to count, we need to tell it. Now I want to create a column. Let me see what are the values which are available in this admission payment date. If you see, if I load all the values, it contains some null values. Obviously, not all leads have been converted into admissions, so it contains null also. It contains date and time also of payment, and at the end, it also contains NA. NA is not good. It is not consistent. Null is fine. Doesn't have any useful information. But NA is a problem. So what we want to do it? Replace NA with null. So like we replaced earlier payment approved. Now right click over NA and replace it with in small letters, write null. In whichever format null is written here, I am writing null. So now it is consistent. Either there is a payment date or it is null if there is no payment. Done. Now on the tab, on the ribbon on the top, where you have home, transform or add column, click on conditional column option. What we want to do, we want to create one additional column with the help of which we can count our admissions. So let me write is valid admission. I'm renaming this new column as is valid admission, or whatever you wish, you can write a name for yourself so that you can remember that okay, this is the valid admission. Is valid admission. So let me tell you once again where it is. Home, transform, add column. So in add column, there is on the option on the top conditional column. So once you click on conditional column, we are going to create one conditional column in the data set, which will be based on certain conditions. So what I will do, wherever this admission payment date is not null, write 1. And wherever there is null, replace it with 0. So we will sum all ones and we will have the number of admissions. So in custom column name, I am writing in the valid admission. And then now let's tell it where on what condition we want to create a column. I want to create a column on admission payment date. So where is admission payment date? So if syntax, it will help us in creating. If admission payment date, I am telling it does not contain in small letter in whatever format null is written, write null. If it is not null, then it means it is a valid admission, write 1. Else, at the bottom, write 0. So look at this. We got first case of problem. There are errors. What is the error? Okay. If you look at, listen, because there was NA in the admission payment date, Excel by default identified that column as a text because there was NA, right? It was not containing all dates. So now once you have replaced NA, one way is you click on this ABC or you right click on this column and there is an option change type. By default, you see its data type is a text. We need to convert it into date. Right? Have you transformed it into date or shall I repeat it again? Yeah, let me repeat it. So, because when we created additional column, it contains error. It could not find. So what we need to do here is this admission payment date, that column, you right click on it, and there is an option transform, or sorry, change type, and change type to date. So now if you see, we have change type here, last step. But now the last column is still error. So what I actually want is that this replacement should have been done in advance. Then conditional column should have been created. So we are using the time machine feature of this Excel. What we are going to do? We are going to shift that last step upwards and that conditional column downwards. So change type, I'm dragging it upward. You hold, click it, drag it upwards. I guess we need to do a little bit more troubleshooting. Still, the last column contains error. Let's see why it is containing error. Or we can go through it again. On the last step, there is a gear sign. If you click on gear sign here, there is a gear sign. If you click on gear sign, we can go back to that step and customize it in case it is not giving us the desired result. So operator is missing here. So now it contains format which is suitable for date. So I'm selecting equals. Shall I repeat it again? So because our last column was containing error, what I did is I clicked on last step gear sign. Because we changed its type. Earlier I wrote contains. Now because the data type has been changed to date, it contains equal to before after comparisons which are suitable for date. So I clicked on equal and value remaining thing is same, null and 1. If you click on OK, now instead of errors, you have ones and zeros. But not does not equal to null. So wherever is not equal to it is null. That should be
1 should be 0 and 0 should be 1.
okay.
All the nulls should get 0.
Oh, right. We should write other way around. So, sorry, we should write wherever it is equals. Earlier it was does not contain. Either you replace it with does not equal, or you replace it with 1 or 0, whichever way you feel like. Wherever admission payment date is mentioned, we should bring 1. So I'm replacing it with does not equal null. Here it should be 1. So this is the best part of this data modeling. We can go back and change conditions. So now we have ones and zeros. Right? So now our model is almost ready. Let me quickly now jump into the report part. Raise your hand in case you have done up to this step. Those who are present here. You are still facing error? So did you replace NA with null? And you also change type to, and then you means that conditional column step also we need to shift upwards. Sorry, bring it downwards. Did you do that? So here change type is should be second last step. If conditional column is there, drag it downwards. Drag that step downwards. Done that? Still it is error? I guess some of you are getting that error could not pass into date. Before, I guess. Those who are stuck with that error, there are two ways to deal with that. If you right click on it, there is an option to, because I've already changed, I guess I need to go back and then see. There is an option to split the column. Can you find that one option? If you go to transform, there is an option split column. Manually, let's help it in passing the date. So split column by delimiter and choose a delimiter as space. And it will, instead of creating one column, it will create two columns. One will contain date, another will contain only time part after space. So split it, and then whichever part contains a date, convert it into or apply the formula on that part only. Those who are getting that error, those who are not getting an error, they can means move to the next part. Or for the timing, if you want to move ahead by ignoring that error,
No one is getting an error then.
no one is getting an error. Right.
Anyone getting an error at the moment?
Shall we move ahead now? These students. Shall we move ahead now? The second bench. Shall we move ahead now? Right. Now let's close this interface and prepare our report, graphical report as well as tabular report. So for that, what you need to do, look carefully. Wherever you have this home section, on its left, we have an option close, and there are two options. If you click on close, this button, close and load to. So we need to click on the second option, close and load to. So once you click on that, it will show you another option, dialog box. First, click on only create connections. Only create connections, and we need to enable this tick box also. Add this data to data model. I'll tell you why it is important. So I'm repeating, by default it is showing like this. We need to click on only create connections, and second option is add this data to data model. And click on OK. So now Excel will start pulling that formatted data into its query mode for generating a report. Once again, because now it is in the process, so it will stop only after pulling the data.
Is it from close or is it close?
Close and load to. There are two options: close and load, close and load to. So we need to click on close and load to. So for the time being, we will ignore errors, whatever errors are coming. Our focus is to make you understand this particular way of connecting and formatting data. Now those I'll again go back. So here I have already loaded, so it is not showing me that option. Let me once again. So those who could not load, you have these options on the top left. You need to click on close and load. On the left of where the file menu is, below file, there is an option close and load. Or you find that option close and load. There will be two options, close and load to. So we need to click on the second option, close and load to. So once you click on close and load to, then by default it will show options, pivot table, all those options. Click on connections, load to connections only. So right now, because I have already loaded, so I'm unable to show you that option. But by default, create connections and tick mark the second option, data model, in case you are loading that file, loading this data set. So if you are ready with the data set, let me know. We need to jump onto the report part now.
How do you know if you already close and load without filter?
So you can go back again. Look at this. You will have this option. Right click here, and there is an option edit. Right below that you have load to.
Yeah.
Right. So you can click on load to, and this interface shows you table, pivot chart. You need to click on only create connection and also click on add this data to data model. So if you want to once again go back and do something which did not went right, you can always right click it and click on edit, and it will show you the same interface where we were operating earlier. Right? So again we can click here, close and load, and you can come back on this. Unless underlying data is updated, it will not do any processing, right? So now, and see, working on errors may be a time-consuming part, so we are skipping that part, keeping the brevity or the time period which we have. Now, due to any reason, let me help you with that. If due to any reason, if you closed those queries and connections, you can always get back to those queries and connection by clicking on data, and then there is an option queries and connections. Right? And now let's create a report. So what I'm going to do is I'm going to click on any empty cell, click on insert, and then pivot table. And in pivot table, I'm connecting from a data model, right? Because we have already loaded the data to our data model. So I'm clicking on data model. So now we have tools ready to generate a report. How many of you have used pivot, Excel pivot options earlier for creating reports? Raise your hand, those who know about pivot table. Only few students. Right. So pay close attention to what I'm doing so that you understand how to generate a report. Right. Look at this. How effortlessly we can create a report by using these options. We have all the data models which we have loaded. I'm clicking on leads, expanding it. On right side, we have 4 boxes. First one is filter, second one is column, third one is row, fourth one is values. What I want is, I want this kind of report. Where, where we have sources on rows and some analytics on the second column. So what I'll do here is, I've expanded leads. There is a lead source. We have bucketed it with the lead bucketing logic. So I'm clicking it lead bucketing logic. Sorry, lead bucketing status logic. It is publisher. So I've just clicked on lead bucketing publisher category. Now, those who are not familiar with this interface, drag lead IDs to values. We need to click it and drag it. You will see it generates some absurd kind of numbers. We'll work with that. So now by default, because it found the numeric data, it has automatically aggregated it by using sum. So what we can do here is, where this sum is mentioned, we can click on it and value field settings. We can change it to count. We want to count all lead IDs. So now report will be updated. We have count of leads. And then the column which we created is valid admission. Click it and drag it below count of lead ID. Because again it is numeric. If it is numeric, it will be. It seems there is a problem. If I select sum, you will see it is giving me certain warning. So it means there is some problem with this particular data, this column. I need to again go back and do some troubleshooting. Let's get that trouble. That error part will not let us work or calculate sum. So what I have done is I have gone to edit connections, and for the time being, what I am doing is because it contains errors. In case it is not containing any error, it is fine. But for the time being, what I am doing is I am removing error rows. Ideally, it should not be done. Ideally, we should look into case by case what is the error and try to resolve it, right? Because we may not have sufficient time to work row by row. So what I am doing here is I am removing errors so that I can demonstrate to the report part. Those who are not having any error, it's fine. And then finally close and load. As the underlying data has been changed, this entire data will be loaded once again. Leads. So you will see it in the refreshing leads. If you know how to pass leads, you could have addressed those errors. by splitting columns. So you see at the bottom it is loading all the rows. So now once data has been refreshed, you can again click, and in case you don't see the fields, you can come back and click on pivot table analyze. Click on this on the right top, there is an option field, and here it contains count of valid admissions. I want to sum it because we wrote 10. My bad. Still we did not choose the correct data type. Let me edit it up once again. The problem is, if you look at this is valid admission column, by default its data type is text. We need to right click and transform it into or change type to whole number. So now once it is done, I'm again clicking on close and load, and this leads will be refreshed once again. So this is how model works. Once your model is ready with all, once it is error free and all formatting is done, then it is next time it is going to take no time, almost zero time to refresh the report. So data has been refreshed. Now again we will go to field list, pivot table analyze, and wherever the count is selected by default, I am clicking it, and value field settings I am changing it to sum. So by default, it seems like all those numbers which were valid, they resulted into errors. So somehow I need to set that right. Those who are not getting any error at this step, it should be fine. But let me set my particular system. So I'm splitting it into column.
Dr. Varun, can I make a quick announcement? I know that the sentence is not working. Just stick to it. We are getting back to you with a new link, which will work. Okay? And complete.
So those who are getting error like me, they can go to the step where before added conditional column and right click it or click on split column and click on split delimiter, click on insert step, and I'm splitting it over space because it seems like certain dates are not being passed. So instead of one column, we will have two columns now. And now I'm transforming it into date. And now let's rename it. Because by default I write the step was wrong. Let me do it on mission payment day. Let me know in case you need any help. So what we have done, date, again I'll convert it into date, only for those who are getting an error because due to some reason it was unable to pass, so we need to manually pass it. So now conditional column, you need to change the column name because that column is now missing. So tweak your columns if you have created additional columns. So I have replaced it with or updated the new column name. So now ideally there should not be any error unless there is something else. And finally I'm converting it into numeric and then finally loading it. It will take a minute to refresh again the entire model.
Guys, QR code for attendance is working now, so you can access it.
Can you create a similar column for is valid application also? Where we have this application payment success, can you create that also? Similar to one which we created is valid admission. So for that, what we again need to do, let's repeat the step quickly for create an additional column at last. To move to the last step, I am creating one more additional column, conditional column, named as is valid application. And wherever this application payment status, let's write it as contain. I guess we wrote payment success. So wherever it contains payment success, it should convey, it should write 1 and else it should write 0. For that type we, I guess again there are certain handles that replace the before. All right. So wherever it is null, it is giving me error, but wherever it is success, it is giving me 1. So what I'm doing, I'm replacing errors with a 0. So let's do it. Let's replace errors with the value 0. And once this is ready, you change its data type to whole number so that we can sum it. So by default, there are certain errors on admission payment column, but we have is valid application now, and now close it and let's create our report. Let it refresh, give it a time 1 minute, and then let's refresh it. So now we have two columns, valid admissions and valid applications. So once it is ready, I'll tell you how to create charts as well as one customized formula, which in Excel is known as slicer or measure. Right, measure and slicer we will work upon once data is refreshed. It is ready. You can click on is a valid application which we created and drag it to the values section. Is valid application by default, because it is now we have converted into whole number. It will sum all the application numbers. So now we have leads as well as valid applications. What I want you to learn is we can create percentage of leads conversion into application. How to do that? Click on pivot, power pivot, click on measure, and let's write a formula to create percentage. So once again, let me tell you how. Click on power pivot, click on measures, create a new measure, and write that name as measure as lead to application, or let's say abbreviate it as lead to app percentage. And in the formula section where we need to write the formula where equal to is written, just press the bracket opening sign. Once you press this rectangular bracket, it starts showing the fields which are available for creating a formula, new formula. So what for percentage, what we want in a numerator, we want numerator of valid applications divided by, again you press bracket sign, count of leads. Right? So numerator divided by bracket, denominator, count of lead ID, and in the format section, click number and convert it into percentage. And by default, I would love it with 1 digit only in decimals. So click on OK once we are ready with this. Right, let me tell you once again. So by default, this is the menu. Here we have power pivot.
She doesn't have that.
What option he has?
Pivot table, analyze, design, and automate, view, reveal.
So I guess in your this file or menu section, in more, you need to somehow search power pivot and turn that toolbar on, right? In advanced or in some toolbar section, you need to just turn on power pivot option, or you can do a little bit of Google search how to turn it on, right? So you'll find that menu option available right at the top. Right. Now let's look at this part quickly, and then you can repeat the process. Look at screen. Now let's create some visuals. I'll request you to look on screen. I'm renaming the columns. D count, application count, and source. If you want to do some formatting, you can go to design section. Dr. Jesh, how much time do you have left? How much time we have left? Right. So let me show you certain quick steps. So open any notebook. Whatever coding tool you are using, PyCharm, Jupyter, I do recommend for beginners. Jupyter is far better. So first, you may open ChatGPT or any tool if you have any extension available. For example, I'm using Windows, so I have Copilot available, right? Else you can directly open ChatGPT if you have that account, or how to load CSV files into Python. So it will tell me about pandas, the data frame which we need to bring in and load CSV files. So if you see, we have data how to load those files, but for that we need to bring this module in. So first load this module pandas as PD. If it is giving you any error that this module is not available, let me know. For that, do you know what to do? No. So then in that case, you need to load command prompt CMD. And then here you need to write pip install pandas. Right? We need to install that package in case it is not available. Pip install pandas, and you click it, it will download and install that package. Similarly, I'll request you, in case you have not installed, install matplotlib also. Pip install matplotlib. So for me, it is already satisfied. So it is saying that it is already installed. For those who do not have, we need to install two packages: pip install matplotlib and pip install pandas.
So this we have to install the Jupyter.
Yeah, Jupyter, before workshop, I recommended to list where we need to bring in. Okay, no problem. Then you will have probably you better to have look at this. Later on, you can install and run it parallelly. So those who do not have these packages, pip install. You can on command prompt you can write pip install Jupyter. That's it, and it will be installed immediately. You Python is installed. Okay, so it will work only in case Python is installed. Sorry, right. First you need to install Python, then only this will work. Right. So if it is ready, then let's load two modules. Import pandas as PD, import matplotlib dot pyplot. So these two modules we will be using for analysis. So now what we need is to load this. We need the path where those files are available. So if you are using latest Windows machine, you can right click on leads, let us say, and show more options. Leads, right click, copy as path. So that path has been copied, let's load it. So files or CSVs in Python can be loaded as a data frame, right? We will work on data frames. And method is read CSV. And to read CSV, because in Python slashes have special meaning and our path contains slashes. So before that, before you copy paste the path, write R before that. R sign, and then it quotes the entire path where that file is. So now let me tell you quickly how that file looks like. If I now click on leads and click on run, it will show you the entire data set which it has loaded. Entry date, lead ID, lead source, and it shows that 10,48,575, or you can say 1 million rows plus 48,000 rows have been loaded. What I'll do is
That spaces in the folder names probably doesn't work.
properly.
The spaces in folder names work.
They work because we are writing in quotes.
I have to.
You need to write the entire path in quotes. So spaces or special characters will work. And for that, you need to write R before that, so that Python ignores these slashes. Otherwise, slash n has special meaning in Python. Now, let me show you quickly the code. And probably I'll give you the code and you can work upon that to generate the similar report. Looking at scarcity of time,
Can we have everybody's attention, please? Yeah.
so there are certain steps which we need to perform step by step to create a data frames. And like in Excel, we created certain additional columns. We need to create additional columns. I'll share that code with all the concerned teachers so that it reaches everybody who is involved in this session. I told you how to load one file. Similarly, you can load remaining 5 files. Whichever folder you have kept in, we just need to write the path here, right? And all these files get loaded. Then the second part which we did in Excel was merging those queries over certain common column. So here, that can be done with this merge command, where you write leads with conversion. PD is the module name pandas, which we have loaded, which supports this method merge. And then you write which file you want to merge with which file. So I want to merge leads with applications on which column, lead ID, and what kind of merging you want to perform, left join. I told you left join, inner join. By default, you keep it left unless you have a certain other objective you want to keep common records, then you can write inner or right, whichever you wish. Then once you load or merge these two files together and rename that data frame as leads with conversion, we can write info to understand what data has been loaded. Now, earlier leads were containing 3 or 4 columns, but now it contains all remaining columns which it found from applications also. Now, similarly, we need to merge leads with conversion with other applications, with other CSV files, which we have leads, bucketing logic, the common column, and method left. Similarly, merge it with publisher column. And once all columns are ready, then like we created customized columns in Excel, is converted to application, is converted to admission. This is how we create additional columns in Python, in pandas, data frames. So leads with conversion, and you write here the column name which you want to create. By default, 0 values assigned. And let me tell you, it is very easy if you write using ChatGPT. If you copy the structure and tell it I have data frame with these columns, and we create a new column named is valid application wherever wherever application payment status. We just need to write in simple English. The logic should be clear. Contains payment approved or payment success. You will see that in no time it gives you the exact Python code which supports it. You just need to give it the clear columns and the condition which you want to write. So we can directly, so it is giving the explanation also, but we can copy paste the relevant. And by default, it is giving me true false. So I want it to be in integer. So convert true false into integer values. So that we can sum those values, 1 or 0, like we did it in Excel. So you see that you will get a code, certain code like this. So once you understand, once you have a little bit of understanding, those means not exactly you can begin coding with from ChatGPT. We need to have certain basic understanding of programming terminologies. Once you that code is available, we can just copy paste it here step by step. The logic should be clear that okay, I want this additional column. Once column is ready, then we start aggregating it. What is aggregating which we did in pivoting? It is called group by, over which field we want to group by source category. And what is the aggregation? We want to count lead IDs and we want to sum is converted to admission. So once you do it, let me repeat all these steps. You will see we have updated data frame and we have aggregated a data frame also, which we created using Excel. So now we have lead IDs and we have is converted to admission. Let's say we want to create another column which contains, let me first Dr. Rajesh? I guess it is enough. Not writing enough code, entire code would be possible. What shall I do? Shall share that entire code or what shall we learn?
Let's share the
All right. Please pay attention. Because looking at the second scheduled session, what I'll do is I'll share this code along with these raw files, and just wanted to bring it your notice that whatever we did by using Excel, that code can be written here with the help of ChatGPT. For example, in this particular code, what I have done already is created charts. Charts can be customized to our satisfaction using color customization, everything, and contains source-wise admission cost also. So that can give you a clear picture of which is the most cost-effective source of admission, right? So whichever is cost, again organic is coming around as the least, the source with least cost. So if I'm dean admissions, I'll put my focus, my budget, though we cannot ignore the other sources, but our focus will be on that source which is most cost effective. So this is this particular session, though it was generally it takes sometimes a semester to teach all these tools and technologies, but we had a very limited time. Uh, what I'll do is we have a recorded video also where step by step all these steps have been performed. Along with that code and video, we will share it with your concerned teachers, those who are interested. Plus, those who have any questions, I would love in case you can note down this particular question which we need to answer from this data set. This is a kind of take-home assignment which I want you to answer. And you can write me your queries and questions on this email ID, or you can connect me with on LinkedIn and post your questions or whatever answer you found. I'll appreciate if you learned something and you can answer that particular question. Two questions we answered, which is the most reliable, not in terms of admission, but what is the most reliable source of application and which is the most cost effective source of admission. But if I have another question, which is the most effective month for generating leads, because the time period on which we need to emphasize or put our most branding budget is also very crucial. So you can answer this third question by working on this data set by using same either Excel data model or by using the Python code. Python code I'll share with your teachers also. And I'll refer in case you can, I'll love also in case you write me on with your answers on my email ID or if possible on LinkedIn, whichever tool you find convenient. Thank you so much for joining. I appreciate, I express my deepest gratitude to the organizers for sharing or giving me the platform to share my knowledge, my learnings with all of you. Hope you continue on the same path. Data analytics is very hot field these days, and it is helping the world in taking better and informed decisions. Earlier, we used to take decisions based on our gut feelings, based on feedbacks, but now decisions are mostly they are driven by, supported by data sets. So, wish that you continue on the same path. Thank you so much for joining. Have a wonderful day. Yeah, please.
Power Pivot, the last person gave
The last column which I made. Right. Let me tell you how to do that. So you have your Excel file open. So she has a question how I created a measure actually. I guess she missed it. Let me tell you how to do it. It is not the correct file. So you want to tell me how to create this particular column, right? Right. What we can do here is you click on Power Pivot. Here we have an option create measures, right? Click on new measures. So by default, this dialog box, which will help you in creating a new column, you can see here. You can name, let's say, you want to create a lead to application percentage, right? You can name that column, whichever name relevant name you want to keep. Now in the formula section, there is an equal to already written. Here you just need to press the bracket sign, right? This particular sign. And as soon as you type it, Excel will start showing you the columns which are available. So if you want to calculate percentage, it means there has to be some numerator, some denominator. So what is my numerator? My numerator is sum of, let's say, varied applications. Whichever aggregated columns are available, it will start showing. So I click on it, then I click on divide sign, right, slash. And then again, I select my denominator by again pressing the bracket sign. And what is my denominator? My denominator is count of leads, right? And then in formatting category, there is an option. I want it to be a number. And what kind of number it should be? It should be a percentage. And what decimal places it should contain? For me, one decimal place is enough, right? Then you just click on OK, and that measure will be available now, right? It means then probably. So once again, I express my gratitude from core of my heart. Thank you so much for joining this session.
Now we'd like to give a token of appreciation to Dr. Varun. I'd like to call upon Dr. Pandey.
First of all, really, it's a very good workshop, hands-on, I will say that. Still, I will say utilize this opportunity to ask questions. I know maybe you have certain questions related with data science, related with statistics, mathematics. Is available. Again, I will request if you have anything, then please ask. Second thing is that I'm really sure that you people understand it. I will not say it's a data science. I will correct it again. I think Dr. Asha is here to understand you the importance of statistics and mathematics. And nowadays, statistics and mathematics are not like it was olden time. You are scared because of the tool is very easy to implement. Okay, so again, try to give a message that focus on statistics and mathematics. That is very important. And with the help of these tools, I think your job is easy. Okay. So thank you, sir. Really, it's very fruitful workshop. Thank you.
Students, those who wish to have a photograph with the
Good morning, everyone. Again welcome you for the second session of the symposium. Now we have Dr. Tamim Bhasha with us. Dr. Tamim Bhasha holds the position of postdoctoral research in the Department of Mathematical Science at Ulsan National Institute of Science and Technology, Republic of Korea. He completed his PhD in mathematics at the School of Advanced Sciences, VIT, Tamil Nadu, India. His research interests span a diverse range of area within the mathematical and engineering domains. As a postdoctoral researcher at UNSIT since February 2023, Dr. Bhasha has been actively involved in research related to the computational learning for engineering and technological applications. Prior to this, he served as postdoctoral researcher in the Department of Mechanical and Designing Engineering at Hongik University, Republic of Korea. Dr. Bhasha research has resulted in numerous publications, including 32 research articles in SCI ESCI index journals and 3 papers in Scopus Index conference. Additionally, he has contributed 3 conference papers to Scopus Index. His research domain encompasses machine learning, blood flow processing, flow modeling, heat and mass flow transfer, fractional numerical computations, and finite difference method. We honored to have Dr. Tamim Pasha with us today, and we look forward to his insightful address on the integrations of mathematics, data analytics, and engineering. Please join us in the extending warm welcome to Dr. Pasha as we commence this enlightening symposium. Over to Dr. Tamim.
Yeah. Good morning to all. So the professor given very brief introduction about myself. So myself, Dr. Tamim Basha, doing a postdoctoral researcher in Ulsan National Institute of Science and Technology. So my presentation is that the machine learning prediction for fluid flow problems using Python. So in this presentation, what I'm going to tell you that some basics fundamental modes about the height transfer, then types of fluid flow problems, then we'll look at about the machine learning, very fundamental things. Suppose if you are interested in future to work on machine learning, so you want to know about that how the algorithm is going to be work. So if you know very well that the next stage is that just adopting the schemes based on your problem, like calling a support vector machine or using a regression model, some multiple regressions, XGBoost scheme is based on all or based on this fundamental. So once you understand that, then you can go further. In this one also, we'll take one research paper which published in ACI journal. By using that, we will use a manual code for regression, and we'll use a package how it will be work. Then we'll use a neural network. Hope the time should be set for us to present all the things. We will see how the machine learning going to be work. So before that, I will give a small introduction why machine learning is important. You are engineering guys, you are working in different domains. Some of them are computation, some of them are experiment. Maybe you are in undergrad, you are in a BTech, maybe some of them in masters. In your end of the semester, you will go for the project. So you are going to work in any one professor's under for the project. So many of them, you will try to publish your papers in good ACA journals. So as an editor, what I want that you are doing computation or experiment, I need a strong validation. So for the strong validation, this is a tool right now has been developing very widely. The call machine learning. They are using this machine learning algorithms to predict or to validate the results. Why machine learning? They are giving much important means that it work with your training data. It's not predicted like an extrapolation within the data set within the interval to predict the result. It use your data, it use your training and testing, it do the validation, then it will do the result. Suppose if you are working a material science guy, the main theme of the material is that you need to find the strength of the material. If you do an experimental investigation, some particular heat only you can apply, like maybe 5 Kelvin or 10 Kelvin or 10 kilo-Kelvin. Apart from that, you cannot be apply more heat to that one. But you want to find that what is actual strength, how much heat I can apply in the material, how we will do that, how we will do the future prediction. That you can do by using a machine learning. You can take the data from your experiment, do the simulation, do the training and testing and validation. Then you can predict that, okay, this is the maximum material strength. I can apply maximum 10 kilokelvin joule for the material. So suppose you are working a biological guy, you want to find that how this hormone level maximum we can give to the any insects. So how you can do? You can do the same as the machine learning model. So in this one also we are going to find a skin friction of a material or skin friction of a fluid flow problem by using a regression, by using a neural network. Let hope it will be enjoy. It will be very useful for you. Maybe those are them going for a final year project. It will be useful for them. So not only in a research perspective, in Korea right now, many jobs in company jobs has called for based on the machine learning, deep learning models. So you are familiar with them as well as academic as well as job purpose. Most both of the way, it will help you for go further. For all the case, the very basic fundamental thing, basic idea is the same one. About which model you are using, up to that you want to be update yourself. So that's only thing. So we'll go for the heat transfer. Heat transfer is, we know that heat transfer from one place to another place due to the temperature difference. It happened in three modes. First of all, conduction, convection, radiation. Conduction is that it happened in the same material from one particle to neighbor particle due to the vibration. Convection, due to the fluid, the heat is transferring from one place to another place. Like we are using air conditioner. Air conditioner fits somewhere. Due to the air motion, the heat or the cool will come in inside and heat has been eliminated. Radiation, the heat emission by electromagnetic waves. Sun is far away from us, but we are feeling the sun heat because it emit the heat energy by electromagnetic wave. So that's called a radiation. So these are the very basics modes of heat transfer. And several laws are available to define a heat transfer. First law of thermodynamics, the second law of thermodynamics. So many laws are there. So it based on your problem, based on your analysis, you can use the fundamental laws for heat transfer. So next major criteria is that major property is thermal conductivity. Why thermal conductivity is important? That I am a fluid dynamics guy. I am working in nanofluid and hybrid nanofluids. So you know that the coolant is based on fluids, like some using some different kind of coolants in your supercars or engines and to cool down the system. Previously, the people used regular water or conventional fluids. It not be much sufficient to cool down the system. So what people researcher has done that they adopted nano level solid materials or nano level particles. They incorporate into the traditional fluids. Then what happened that the heat transfer is enhanced. How the heat transfer is enhanced mean that compared to fluid cases, materials have high thermal conductivity. So with this case, the nanofluid is complete research domain recently is developed not only in one particular field, it is applied in solar energy enhancement. For all the cases, heat transfer rate is very important. It based on the thermal conductivity. What type of material you have chosen, based on the cost, based on the effective, it can be applied in your vehicles or in your systems. So if you are analyzing your thermal conductivity is to be a constant, you can take a constant thermal conductivity term. Suppose it will be variable, you can take a variable thermal conductivity. Variable thermal conductivity means that the temperature is depend on some term like an exponential term. Okay, if it is be a normal, it will take constant. If temperature is thermal conductivity is 1, it's a constant thermal conductivity. Then that thermal conductivity of different materials like a polymers, ceramics, and metals. You know that metals has high thermal conductivity. So, that's why suppose you are a mechanical engineer in your research in your project, you have this ANSYS fluent you will use frequently. There you have the channel. There you analyze the heat transport into the surface or heat transport over the surface or heat transport into the surface, all different alumina. Suppose if you are working in ANSYS, there itself the thermal conductivity has been inserted. You can call this alumina, you can call the steel, you can apply that model. The thermal conductivity is a combination of electron transport into the medium and weak bonding. If you know that the fluid has a weak bond, so the heat, the strength, like energy cannot be transported easily from one molecule to another molecule. But if you go to the material, it's very strong and full of vacuum places are there, so heat energy can be easily transferred. That's why metals has high thermal conductivity when compared to polymers and ceramics. Now we come to the fluid dynamics modeling. I won't go more deeply because some of them have been bachelors or masters. So I just say only outline why this modeling is important. It will be very useful. Suppose if you take this is your problem for your futuristic, then you can go with this one on deep analysis. In fluid flow modeling, right now we are working in 3 cases as a mathematical perspective. In mechanically, CFD is very big domain. If you come into the over outline, this is 3 cases. First, fluid flow over a surface case, fluid flow over a fluid into the channel case, and fluid flow into the container. Fluid flow over a surface case is a very traditional or it's a classic fluid dynamics model, which means that there is a surface. When fluid contact with the surface form a small thin layer, they call the boundary layer. So inside the boundary layer, the velocity temperature gradients are notable. And this boundary layer classified as a laminar, transient, and turbulence. So this particular modeling has been most important in like aerodynamics and aircraft modeling. So I'm working with one of professor from Stanford University, Professor Anwar Beg. He's working in aerodynamics modeling by using the fluid flow problems. So he's much familiar in this one. So we learn this concepts from him. So there is a aircraft wing there, how the turbulence is happening. If turbulence is more, the flight fast is going to be reduced, as well as you will face some difficulties during the flight time. So your main theme is the reduction of the turbulence according to your material or coating surface you can control. Okay. Not only that, you can apply for cooling your electronic chips or electronic equipments. The fluid flow or a surface case has been important. Then fluid flow in a channel case. Suppose you are a biomedical engineer, you want to analyze blood flow into the artery, blood flow into the stenosis. You want to analyze blood flow into your blood clot region. On such a case, you can take a fluid flow in a channel case. So there is some artery, it will be closed surface, the fluid into the inside the surface. It's called pulsatile flow or peristaltic transportation. Our stomach to emit our wastage by using a peristaltic transportation. So these are all based on the channel flow cases. The next one is fluid flow in a square cavity. This is a very famous research right now is going on. There is a square container contained with the full of fluid. Due to the fluid interaction, how the heat transport is happening. Suppose let us assume that you have a container full of petrol. So what happens if you make shake the petrol some particular time, due to interaction of molecule, it's going to be blast. So how you control the heat inside the chamber? Like suppose you have a petrol tank in your car. The coating they made it by to cool down the chamber. That time only that interaction going to be slow down and the blast going to be stopped. Okay, so here you see this example. This is one of the published paper module. So they taken a module of computer chip. They consider several fins inside because the the module contains several fins. So how heat transport is happening? I'm in Korea. In neighbor, there is a microfluidics laboratories there. You know that we are working. We have this type of mobiles with full of a solid like a solid surfaces. Now they are working full of microfluidics mobiles. So they are working with the Samsung company. They are doing this research. Now in future, you don't have any kind of solid surfaces. It's full of microfluidics. You can flip, you can rotate, whatever you can do with your mobile. So such a type of advanced research is going on by using a microfluidic systems. So on such a cases is fully based on the fluid flow into the square chamber cases. Now we come into the machine learning. Machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So in machine learning, we have 3 categories. First is supervised learning, unsupervised learning, and reinforcement learning. Supervised learning means that you have several information, like you'll take fruits, apple, banana, orange, many things are there. So you are telling the computer, hey, this is apple. This is if it's lengthy, that's called banana. If it's this kind of elliptic shape, you can take as an orange. So you are giving a information. From the information, it giving a predicted solution. This is banana, this is orange. Suppose you are not labeling anything, you are not feeding any information to the computer, but you are giving just set of fruits. But the computer want to predict how it, such a type of modeling called unsupervised learning. From his data, he understands that this is a banana, this is the orange, this is the apple. The reinforcement learning is totally different. Because of that, it learned from his own experience, like it is own faults and merits and demerits. It's learned. This is a very advanced research is going on in reinforcement learning. For example, I'll give a simple example. Now you are all are vaccinated. What is mean vaccinated? They take this COVID cell, they remove, they took the protein, they injected to us. So when our white cells to look at this alien, it understand that, oh, we have to attack this fellow. So how the white cell has been learned from that, because from the protein molecule it will be understand, oh, this is not fit for this is not good for our body, so we have to attack. Suppose you are not vaccinated, what happened? It doesn't have any information, which means the white cell doesn't have information, then it won't be attacked. As similar, if reinforcement learning, it learned that, okay, this is not good for us, this is good for us. From that experience it will be understand. So that kind of advanced computing, it's called reinforcement learning. Now, what are the types are there if you go into the supervised and unsupervised reinforcement? So our presentation fully focused on supervised learning. So in this supervised learning, we have a regression model, classification, deep learning. Regression means that you have the data, you need to predict some data, it's not in your data set. That's called regression model. Same thing you can apply in deep learning also. Then classification, suppose some data has been given as a medical data, you want to find out who guys are diabetic, who guys are non diabetic from the data. That means you have some threshold value. From the threshold value you classify that these guys are diabetic guy, these guys are non diabetic. So that type of new machine learning models called classifications. Okay, then next comes deep learning. In deep learning mean it based on the neural networks, neural network going to be incorporated here. So it do both the operations, regression also it will be do, it do classification also. In deep learning, very famous, recently very famous developed neural network called convolutional neural network. It is applied in many domains, especially for image recognition or highway. Suppose you are going, if you are going in highway, there are different lanes are there. 80 kilometer per speed lane is there, 100 kilometer per speed lane is there. Suppose if you are going 100 kilometer lane with 80 kilometer speed, if the highway camera will capture you, it detailedly capture your number board. It will send you the, okay, this fine in 100 kilometer lane you went 80 kilometers, so you have to pay this much fine. How that image has been captured more clearly? They are applying convolutional neural network. Defaultly it has been stored. It will take your car information or size information, it will go exactly your number plate. There is some zigzag information will be there. By applying deep learning, it will make more clarity, then it find your car number, it will send. So like that, the convolutional neural network, for such a cases, convolutional neural network has been used. Clustering is this clustering and dimensional reduction, it has been unsupervised learning. Maybe in future, if you want to be used in your modeling, we can go with these cases. Okay, now if you're coming into the machine learning picture, in machine learning, when you are working, our main theme is minimize the cost function. What is cost function? You have actual value. You are predicted by using by using your computation, you find the prediction. The error between actual and prediction average is called cost function. Our main theme is we need to reduce the cost function. If cost function is reduced, automatically your actual and prediction has been equal. Okay, if cost function is high, your actual and prediction difference is high. So when you are working a machine learning model, you have two parameters, weight and bias. Initially you choose some weight and bias, you need to do the simulation, you need to do the computation. From that you calculate the weight and you calculate the cost function. If cost function is high, then you need to do update your weight and bias, then you have to find the, you need to reduce the cost function. This is a step A. So we will see one simple code that how to apply how the cost function has been worked. Okay, so this whole presentation I am using a Python. My software is called Anaconda. It is freely available in internet. Why Python is very important? Because it's a free of cost. Suppose you are working ANSYS, COMSOL, MATLAB, it has been paid softwares. It has been more expensive some cases. So that's why if you are your future, if you has been a researcher or you are going to work in any field or any academic jobs, they are preferring that you are familiar in Python because it's free of cost, no need to spend particular amount for that. Okay, so I used Python Anaconda. My compiler is Jupyter. So many notebooks are there. As per your convenience, you can choose it. Suppose you are a beginner, you don't know about what is Anaconda, what is Jupyter notebook. Simply you can go to Google Colab. All packages has been installed inside. Just you call it, you run it. But if you are working in Anaconda, which package you are going to, suppose you want to work TensorFlow, you have to be installed manually TensorFlow. That is to be very difficult. So initially you can go with the Google Colab. Once you are familiar with the Google Colab, with the programming or anything, then you come to the Jupyter Notebook or on account. Okay. So if you are work in machine learning or any other computations by using Python, many libraries are available. So you need to call the library which is suitable for your analysis or suitable for your computation. Okay, that is a very basic fundamental way of approach. So here I'm going to use sklearn matrices for regression model. Sklearn has developed many libraries, so I just call the package. In this one, I'm going to use mean square error. Mean square error is difference between actual and prediction. Difference between actual and prediction with this average is called cost function. Only difference between actual and prediction is called mean square error. Okay, so we need to call this package first. Then let us see, we will take some data x train. X train. Let us go. I choose like a 1, 2, 3, and 4. Then we'll go Y train. We'll take some data initially. The Y train. Y train will take a 5, 8, 10, 12, maybe any values randomly. 5, 8, 10, and 12. So this is called our future. This is called our predictor. We need to predict. So this is our y things. Okay. Then we have feed the data. Then what we want to do that we'll choose some weight and bias. Initially, I will choose some weight. Weight and bias are the two parameters in our machine learning model. So I will choose weight is 2 and bias is let us take -1. Okay. So first I will run this one by one. You just look at. It takes some time because this Jupyter Notebook will work in online, so we need a good internet also. Yeah. See, now we ran this. Let us see the prediction. Let's look at the prediction. Yes, our value is we need to predict 5, 8, 10, 12. But what we predict is 1, 3, 5, 7. Based on weight and biases, we predicted this one. Now just look at is cost function. What is cost function? See, for this module, we got the cost function is 11.38 and mean square error is 22.75. So for this weight and bias, okay, for this weight and bias, we predicted like this. Definitely, actual and prediction has been so much difference. Correct? It's not be clear. That's why we got a high cost function. Now, what we want to do that we need to do the cost, reduce the cost function. So how to do the cost reduce? How we will reduce the cost function? That's called optimization approach called gradient descent. Gradient descent means that initially we will choose weight and bias here somewhere this weight and bias values. Okay, gradient descent is a numerical approach. It will go in reverse direction to find a global minimum. So here somewhere we chosen initially some values here. By using gradient descent, it will come to find a global minimum. It's called optimization approach. Okay. So if global minimum has been find out, what happened during your iteration, your actual weight, which means predicted previously, during computation, what you got, both will be same. So as similar, your bias both has been same. Then you stop your computation. On case, what mean that your initial weight, your previous iteration weight, present iteration weight, both have been same. Then the cost function has been reduced. Then you got a better prediction. So how to do that? This is our cost function formula. So which we seen here, that we need to differentiate one time with the learning rate parameter. See, we need to differentiate. Then this is our differentiate form. So from this differentiate form, we have to apply in program as similar for weight and biases. Through this formula, by gradient descently, each iteration, the weight and bias is going to be updated. Let us come to the same program once. So initially what we got that 11.38, correct? So again, yeah, for this we'll see the results. Let's take time. Here our actual value, but what we predicted is this blue color line far away from the result, which means it's not near to us. Now we are going to do the optimization by using gradient descent. So the learning parameter I choose 0.1. I will explain the next slide about more clearly about the learning parameter. Learning parameter is hyper tuning parameter. It will be very important. I will tell you that range what we want to use. Okay. So this is the formula for the weight. This is the formula for the bias, which is shown here. Okay. This is a formula for bias, sorry, weight, as similar for bias. So same we are applying here. Once we apply the optimization, what happened? What we initially given the weight and bias, it will be update. It will be give a new weight and bias. Yeah, it has been calculated. Now see the mean square error. Right now. See, previously we got a cost function 11.31. So now we got the cost function is 1.31, which means our weight and bias has been updated. Previously what we given a weight is 2, bias is -1. Now you see weight is updated, weight is 3.225, bias is minus 5.2. Okay, so it has been updated. Now you see the result of after updating the, see our result, how nearer the line has been kept. Previously our line is far away. Now from the actual where the values are there, the linear line has been moved forward. It come nearer to our predicted value, actual value. So now see the differences before using optimization. After applying optimization, see the differences. See, we are not applied any optimization based on our cases. Our blue color line is here. After, by using optimization approach, the weight and bias has been updated. The curve has been moved. As similar way, you can update each iteration your weight and bias. It will come nearer to this. Then you will get a better prediction. Initially, we choose weight is 2, bias is -1. During this gradient descent approach, one step, it will coming to find a global minimum. Now see that result is 3.25, weight is updated, bias also updated. Okay, so as similar way you will get the better result by using regression. This is simple example how it is working. Now we just go that learning rate. Learning rate is this parameter called hypertuning parameter. There are several hypertuning parameters are there to enhance your complexity of the code. If you enhance the hypertuning parameters, you will got a better prediction and you will got fast computation and better efficient computation. Okay, so what learning rate parameter is that? Actually, I am following Professor Andrew NJ. He is from Stanford University. So he have a AI laboratory. I learned the course from him. So from his suggestion that the learning rate parameter is not more than 10 to the power -3. If it is go more than 10 to the power -3, definitely your system going to be failed, which means you got some good training result, but validation will be fall. Okay, so what you want to do, suppose if you are if this range we have to take initially 0.1, then you can update 0.01, then you can go 0.001. Suppose for this case also you are not getting a better prediction, so you can go 0.3, then 0.003. So like three level you can update. Definitely any of one case it will be good. So what is learning rate parameter? So how it will be work in that one? So suppose we choose a weight and bias here somewhere we have chosen. So we need to go to find a global minimum by step, not fastly. So step by step we want to come. If learning rate parameter is small, it will come smaller steps to reach the global minimum. Suppose if you give a high learning rate parameter based on your computation, initially it will choose some value weight here. After that, what it will come? It will go somewhere here. So it will zigzagly, it will go to find a global minimum. It will spoil your result. You won't be get a better prediction. So you need to go step by step to find a prediction. So then only you will get a better slow by slow computation. Then only you get a better prediction. So this is main duty of learning rate parameter. Then if you're working a machine learning problem, you will face some difficulties is called overfitting and underfitting difficulties. Overfitting, underfitting, that suppose you have this type of data, like some data is there. So you try to capture all your predicted value mean, the data will called overfitting. Suppose you are not capture many data points, this is called underfitting. So what you want to do that, you need to make your level of curve nearer to this. Suppose you have data like this, linear data. For this linear data, you will apply polynomial regression. What is going to happen? It will capture all data points. If it is capture all data point, it's going to be overfitting, which means that, you know, when we are working machine learning, we need to split our data. So it will be training and testing. in training, you will get better correlation, performance matrices, but in training, it won't be good. It will be fall of performance matrices. If it will be fall of performance matrices, automatically you won't be get an optimal outcome. So during a competition, you need to take a best fit. That time only you will get a better performance matrices, as well as you will get a better prediction. So how we know that our results are overfitting and are underfitting? By using when we are going to plot our training and testing plot. So this is our training plot, our testing plot. Okay, our training plot is converge, but testing plot is far away from the result. See here, somewhere it's going to diverge, which means that the results has been not been matched properly. So this is called overfitting. So, but there is a huge small gap will be there in between. This is called underfitting, because the problem is the program which you wrote and which you've written, it's not good. So what it will be there, right? Your training and testing should be near and converge. That time only your model will be best fit. So how to cure? Suppose you are overfitting, you can apply regularization. Suppose it is underfitting, enhance your enhance the hypertuning parameter called learning rate, or use iterations, enhance your iterations, call early stop. Like many hypertuning parameters you can incorporate, then you will get a better prediction. So if it is a overfitting, what we want to do, that we need to apply a technique, it's called regularization, which means that we are adding some penalty term here. The penalty term control our data for overfitting. Okay, see here, this is some data has been pointed over here. So if I am applying a polynomial regression, definitely what is going to happen, the curve will be polynomial, it will be capture all data points. If you capture all data points, definitely what happened, my training will be good, but testing has been failed. So what you want to do, that you need to apply this regularization. It will control your predicting all values. It will find which is more suitable to find most of the values. So like this curve is be a best fit curve. Okay, so for this case, two types of regularizations are there. One regularization, we are adding absolute value of our weight values. Another one is the square of our weight value. Okay, if these two penalty terms you have added here, you can control your overfitting, then you will get a better result. Okay, so when we apply L1 regularization, when we need to apply L2 regularization, suppose you have n number of features. Some features are only very important, other features are not important for your simulation. Then you can go L1 regularization. No, for all features are important for me to predict my result, then you can go to L2 regularization. Maybe suppose if you are working based on your problem, based on your module, you can choose what type of regularization is needed for your problem. Okay. Now just look at this research paper. When I was start my initial work, I was choosing this paper because this from our VIT professors. If any doubt, I asked them. So for the clarity purpose, so this is a research paper published in Elsewhere journal. This journal has right now is 4.5 impact factor, which is Q1, and SCI journal. So in this paper, they have certain data. They applied artificial neural network. I will tell you that how to apply a multiple regression and how to apply a simple neural network to predicting the result. So before going this, I just explain what type of modeling they have done. That they consider fluid flow over surface case, which is I've shown the earlier modeling. So they consider circular cylinder. The circular cylinder fluid is over to the surface. It will form a layer. It's called a boundary layer. Okay. So here they consider Casson fluid parameter. Casson fluid as their Casson is their fluid. There are different fluid modules are there based on the suppose you are working blood. Casson fluid is similar to the blood case. Suppose you are working crude oil, on such a case Williamson fluid is good. So it has been developed based on the rheological model which is available in nature. Okay, they chosen Casson fluid. They chosen different parameters, different physical disturbance into their modeling. They analyze the heat and mass transfer behavior. So they defined continuity, momentum, energy, and concentration equations. It has been based on the conservation laws. Continuity for conservation of mass, conservation of momentum, conservation of energy, and conservation of mass transport. For all the cases, they applied the conservation laws. They defined the governing equation. They solved by using Rengekuta method, numerical technique. This is their numerical result. This is they predicted by using artificial neural network. So these are the parameters which from their problem. magnetic field, Darcy number, Prandtl number, Smith number, Cason-Fried parameter. So these are the data they have. Okay. So what we are going to apply? Suppose you want to here several parameters are there. So it making a disturbance in skin friction factor. Suppose you want to know only one parameter, like any parameter, choose magnetic field only, how it is affecting the fluid transport, or you want to know how Prandtl number only affecting the fluid transport, then you can choose a simple linear regression. Instead of this way feature, you can choose like a magnetic field, or you can choose like a Prandtl number as per your convenience. No, I just want to know all features how if affecting the fluid transport. When you can take a multiple regression. So all the case based on your model, based on your what type of analysis you are going to do, you can choose the features. So then you can we know that if the model we need to find the cost function, we need to reduce the cost function. If single parameter, single linear regression, the weight is single. If it is the multiple regression, it will be a vector. Then you can go for the gradient descent to optimize your weight and bias. Then after you can do the training algorithm, then you can find the result. So we know that mean square error and R square is our performance matrices. Mean square error, we need to reduce the mean square error, go to minus 10 to the power 3 or 10 to the power 4 level. How much mean square error going to reduce, that much your actual prediction has been same. R square error, this is a performance matrices. So we will calculate from 0 to 1. Okay. If your R square is nearer to 1, like a 0.8 or 0.9, then you can say that your result or actual and prediction have been good correlation. Okay. If it is nearer to 0.99, then you got a best result during your simulation, during your performance. It has been good correlation with actual and prediction value. So how to build by using regression model? So what we want to do that, I'll show these results in these two programs. The first thing is that we have to develop all the things by using manually. We have to type manually our cost function. We typed manually gradient descent. Another way that there is a packages available called linear regression package is available in sklearn. We can call this one how it will going to be work. Both the things you can know. It will be very useful for you. So if you work any numerical approaches or any number operations, you need to call the packages called pandas, or you can call the packages numpy. Pandas mean if you are uploading any data, they called a panda. You need to call the package panda. Then if you are using number operations, you can call the numberpy. If you are using projections, you can call matplot. So according to your problem, you can choose. So once we upload the data, what we need to do that we need to split our data for training and testing. So here we chosen that testing data is 0.2, which means that our training value is 80%, testing value is 20%. So like that, we need to split our data. Okay. Then we have to predict our initial weight and bias. Then we need to calculate our cost function. Once cost function has been calculated, then we need to optimize the cost. We need to optimize our weight and bias by using gradient descent. Once this is optimized, then we get the better result. Let us go with a simple program, how it will be work. So you just here, we call this panda, we call numpy, we have a plot, so we call this matplot package. Then we are going to evaluate performance matrices. One is mean square error, another one is R square. For testing and splitting purpose, we are calling the same sklearn package. Okay, just see the program, it's working. Yeah, it takes some time to run because it recall all packages is available into the Anaconda. It takes some time. Now just look at again the same package, whatever we called here, the same. Only thing is that the standard scalar we are calling import extra package from sklearn. The same data we are reading here. So the same column, same data, everything is the same one. So only thing is that we added in this one the scalar standardization. Let's see how it works. Yeah, it's run. Now you check it. The same data which we called. Now we did the scaling. We'll see. See, I told you that we need to split our data for training and testing. So we splitted. These are the data for training purpose, and some of the data has take, which means 80% of data for training and 20% data for testing. So here I given random state is 42. Random state 42 means that we have a data. It won't be taken in order. We need to shuffle the data. From the shuffle, we have to choose the 80%. So the random state is 42 means that here it given 21. So if you give random state is 1, you just see how it shuffled and data has been taken. See, previously the first data is 21. Here the first data is 25. So there is no matter that how much value we can take. You can take your birth year also. You can take whatever. Like I choose 2000. So see how the shuffle is happening. See, initially 16 has came. So it doesn't matter that what is a random state. Why we are giving a random state me? Today you did the simulation. After 1 week again you want to do the simulation. That you are not mentioned random state what going to happen. It shuffle in one way. So each time your result going to be changed. So if you give a random state is the same one, whatever time you are doing the simulation, all the time you will get the same result. That's why we are doing the random state. So now the shuffled again we are going to predict. Let us see the prediction. Then we have to find the cost function. We are optimizing by using gradient descent. Now we are called the learning parameter. Now look at the actual prediction. See, previously what we got when we are not calling the standardization, our actual is 1.7479, our predict is 1.6030. Now you just look at here, our actual is 1.7479, our predict is 1.7. It's almost nearer to that. Now we will check about the from via the performance matrices, how the mean square. Yeah, see, mean square error is 10 to the power minus 3 level, and our R square is 0.93, which means our actual and prediction has been good correlation. Okay, so like that way, if you are writing in a scratch code, suppose you want to use a library which available in sklearn, it will be more convenient. No need to bother about to optimizing the gradient descent at all. It has been inside, all the things will be there. Just you call the package and implement it. So just look at here, the same thing, same everyone. Only thing is that we call this module, we fit the module. Just look at same data set we have taken, we ran it. Yeah. So only thing is what we done is when compared to previous one, here we call a linear regression model from the sklearn model. The only thing is that we have done. So now the same data has been taken. So we trained our module. So this is our X train, which means that we splitted a random state 42. We splitted our data. Then we call this model linear regression. Okay. Then we fit this model. Once it's fitted, now just look at our actual and prediction. See the our training R square and testing R square. So see, previously we got here 1.71 by using our own written for gradient descent and cost function. Here we have not elsewhere mentioned what is our gradient descent, what is our cost function. By just calling this package itself already pre-programmed is there. It will call that one, it will do the operation and everything. Just we need to call that package, which package is relevant for our modeling. It did all that. It did all the things. C is 1.7479. We predicted is 1.775. Here 1.52. Here 1.51. Now you just look at for training, R square is 0.99 and his mean square is very less. Our testing R square is 0.99. Our mean square is 0.0031. From this, what we can understand that our result is not overfitting. our result is not underfitting, it is a good fit. If it is overfitting, our training will be good, testing means R square error will be low. But here all nearer to 1, so our training and testing has been good, so it's not overfitting, it's not underfitting, it's a good fit. So now we can see the coefficients. So this is our coefficient equation. I just tell you that why we did this analysis. So what is the use of this? See, I'm working in fluid dynamics model. I'm working in numerical techniques. So each fluid have different Prandtl number. So I took Prandtl number is 0.72, which means that it is an air Prandtl number. Okay. During a computation, if you take Prandtl number is high, maybe 1000 or 2000 or 3000, computation won't go because some certain level only the computation is going to happen. But I want to predict what is, suppose in Prandtl number is 10,000, Prandtl number is 1 lakh, what would be my skin friction factor? I cannot be do because of the computation has been failed. We need to enhance our we need to find a new numerical scheme. It will be very difficult for our simple data prediction. So what we can do that we can call this machine learning. By training, we can predict that suppose if Prandtl number is 10,000, Prandtl number is 2,000. You just look at here. Initially, we given the Prandtl number is 0.71. I given the same 0.71. It's a air Prandtl number. See, my prediction is 1.6074. So it is be here. 1.60, 1.6. Prandtl number is 7. 1.6074. 1. Maybe some 1.60. 1. Somewhere is, yeah, maybe somewhere it will be there. So what I'm going to do that, if I'm taking Prandtl number is 6.2. 6.2 Prandtl number is of water Prandtl number. From experimental it was proven. See, if Prandtl number from gas to fluid is going, the skin friction is going to be more negative, which means that the fluid staying over the surface is making rough the surface. Suppose if I'm going kerosene as a kerosene fluid, my fluid is a kerosene, then just look at kerosene Prandtl number is 10. Now we said look at still more negative. Okay, some future someone has been predicted the Prandtl number is 1 lakh, maybe 10,000. They find out some fluid, its Prandtl number is 10,000. Then what is the skin friction? It is minus 3005. So if using a if you adding as a fluid different fluids like a liquids, your skin friction going to be affect much more. So if you going as a air like a 0.1 is an helium gas, now you can look at his Prandtl number. Oh, it is in positive. So the air cases is not affecting the surface. The liquid case is going to affect the surface. So like that you can write in your manuscript, or you can give the results when you are working. It will be very good for the publication purpose. So like that we can apply the linear regression. Now you can go to the neural network. Why neural network is important? So here one of my friend is there, he's a computation fluid dynamics guy. He's working in combustion analysis. So his whole domain he measured with 1 lakh grids. But for computation purpose, he taking 3 months to do one simulation. If he did any mistake, again you need to run the code for 3 months. So what he can do that, what he did that, he seen his domain. Okay, where he need a fine mesh, there he enhanced the grid size. Where he seen that pressure or heat transfer is very less, or it will be noticeable, there he reduced that places he reduced the grid sizes. From this, he reduced 1 lakh grids to 65,000 grids. Then he did the simulation. Within 2 months, he finished the simulation. This is a very simple example which I faced in real life. So as similar that when you are working in different modules, based on your problem, you can apply the neural networks. Okay, in your academic perspective. If we're coming into real life problems, here we have HS, high voltage heater systems. So what it will do that we are living in a cold country. So here sometimes it go -3, -4. All the time we cannot be adjust our heater. Okay, so what is going to happen? It will see atmospheric outside temperature. It see inside temperature. Due to deep learning, the system automatically update will give to the heater to us. It will give like a temperature, or this much temperature it will be maintained. So like this kind of advanced AI technologies has been by using neural network in electronic equipments. Many places it has been applied. So that's what the neural network is very important. In recently, what happened that one of the research journal is called Emerald Publishing International Journal of Numerical Method Heat and Fluid Flow called for a special issue for only for neural networks because that much importance has been grown in fluid flow problems for neural network. So if you are applying a neural network, it should be a big domain, but I'll give you a simple example. Uh, the architecture of neural network, or it will contain first of all input layer, then after it contain a hidden layers, then it contain output layer. So input layer information passes through the another layer by using activation function. So regression and neural network both have same, but in regression you don't have any type of activation function. But if you come into the neural network, there is activation function. This is only difference between a neural network and regression. Okay, in regression you doesn't have the activation function. If you come into the neural network, you have the activation function. Each module has a different type of activation function. It's called sigmoid activation function, rail activation function. Most famous for computation purpose, the people are using rail activation function. So it has been different equation. So each neuron, the information passes through another user by using the activation function. Okay, so like you just see here, you will take this particular node hidden layer 3. These node informations come from this neighbor node by using the activation function. It passes through output layer also as a activation function. So each layer you can use different activation function also based on your complexity of the problem. Okay, so how to build neural the same model by using neural network? So if you are working in neural network, you need to use a package called TensorFlow. TensorFlow is a very famous. It was developed by Google. Still, many development is going on. All mathematicians are working in the development of TensorFlow. If you are familiar with TensorFlow, you need to know about the PyTorch also. So if you both this familiar with this TensorFlow and PyTorch, it will be very good for the company jobs. Recently, I applied for Facebook Meta for Tensor for my job purpose because I'm working in TensorFlow right now. They are developing TensorFlows for future predictions by artificial intelligence. So if you are familiar with the TensorFlow, you may get good opportunity in future. Okay. So here also same, we need to call for a TensorFlow called TF. Then we need to train extend and Y train. The same, we are splitting like that. Then we need to make an like a neural network architecture. Neural network architecture, the input layer hidden. This is a input layer. Along with it work as a hidden layer. So I call the activation function ReLU. So the same next layer also mean hidden layer, same activation function. Then this is the output layer. So our regression problem, we used gradient descent for optimization purpose. Here we are using Adam optimizer. So there are different optimizers are there. Stochastic optimizer. So here I'm using ReLU. Here I'm using Adam optimizer. Okay, as per your model, as per your convenience, you can take what optimizer is important. Then we have fit the our model. After fitting that, we find the evaluation performance matrices by using mean square and R square. Then you can get the result. See the program how it is working. This is also very simple feed forward neural network. Okay, you can apply convolutional neural network. You can apply a recurrent neural network. Suppose you are going to predict financial problems. Very famous scheme, very famous is recurrent neural network. The people are applying to financial prediction by using recurrent neural network. If you are going to image processing, you can apply convolutional neural network or GRN, graphical recurrent neural network. So based on your problem, you can choose the different neural networks. All the neural networks or all the regressions, basic concept is same, reduction of cost function. Only thing is that based on your problem, which model, which method you are going to use, so how it will be work that you can understand is fine. So here we call the same packages all the same. Only thing is that we call this package called TensorFlow. See, it will take some time because of TensorFlow is a big package. We have to do manual installation. So it takes some time. It will go to an agenda. It will analyze TensorFlow package has been installed or not. It will be recalled. It takes some time. So what we done is here, we split our data as a different 8 batches. So you can enhance your batches also. These are all hypertuning parameters, batch size, epoch, learning rate, or all the hypertuning parameters. If epoch mean that previously we call an iteration. Here we say as epoch. Why is the name is different? Because iteration means you know that if you are working in numerical computation, one step information, then go to next step information. But epoch is not like that. We have 8 batches. So one batch is complete, we call one epoch. So like one data set, it will go for 8 batches. So 8 batches has been complete, one epoch. So like that, it ran 800 epoch mean it will run at 800 times. Okay, so that's what is called an epoch. So same, we call the data, save as CSV file. Now we just look at, yeah, we trained our model. As similar, we are splitting training and testing. Same, I'm giving 1993. As per your convenience, you can give 42. It's very famous because very all very basic researchers, they are using 42. I don't know what is the fashion in that word, in that number 42. As per your convenience, you can choose it. So we can this is our neural network architecture. I'm using Rayleigh activation function. You can use TANH activation function or sigmoid activation function as per your convenience. In this research paper, they used uh, let's go. Yeah, in this research paper, they used a sigmoid activation function. Sigmoid activation function usually best for logistic regression problems like classification problems, but they applied here sigmoid activation function. But I'm not applying activation sigmoid. I'm using Rayleigh. It will be more efficient than that sigmoid activation function. Now we can call this Adam optimizer, because I told you right previously in regression problem we are using gradient descent, here optimizer. So different optimizers are there, stochastic optimizer. So many optimizers are there. As per your convenience, you can choose the optimizer. As per your problem complexity, you can choose it. Now the iteration is going on. So here we mentioned that where boss is 0, where boss is 1. Where boss is 1 mean it will give each step informations. If where boss is 0, there is no information, it will just give the outcome. So I think the iteration is going on. Take some times. Yeah, it is completed. Now see our R square and mean square value. See, our mean square is 0.008. Our R square is 0.005. So it's not a proper fit. We will update it. See, the difference is our actually is 1.74. Here 1.711. So what we can do that we will update our we'll go with little hypertuning parameter, and I will shuffle the random state in different way. So what it has been given initially. Shuffle also sometimes will make a sense. So we'll clear the output. We will run it one more time. Restart and run. It's running, it takes some time. Yeah, step by step it is coming. Now it came to this batch size step. So it will be shown the outcome in so. So likewise, if you are applying, if you want to enhance your architecture, you can enhance the architecture. So if you want to enhance your neural network node, also you can enhance it. So based on your architecture or based on your model which you are using, it will give the best result. So based on your complexity of the problem, based on the data which this is a numerical data, so definitely we will get some good correlation. Suppose if you are going a large data set, maybe 10,000 data set, 1 lakh data set, like that type of data analytics you are doing, then you can enhance your complexity of architecture, choose a best neural network model, and you will get a better outcome. Choose a best optimizer. You can use stochastic optimizer or gradient descent optimizer. So many optimizers are there, so you can choose the best optimizer. But people are mostly working for regression model is Adam optimizer. Suppose if you are working classification model, they are using a cross entropy model, cross entropy optimizer. So as per your problem, whether it's a classification problem, it's a regression problem, it's a image processing problem, as per your as per your uh, problem, as per your approach, you can choose it which is more convenient. Maybe I will give a let us see why it is stopped. I don't know. Let us clear all output. We'll go manually because it's not running, it's taking some time. Again, it will take some time to run this TensorFlow package. So once it be run. Then other things will be very easy one. I'll take random state is 42. It's more convenient. No need to this one. So let us wait some time. Maybe. So we have still 3 minutes to finish it. It's running in TensorFlow because yeah, it's run. Now we'll go step. Yes. So we same. Oh, no need to go much one. I'll give the same one. Only thing is that I will change this one architecture 32 instead of that I'll give same 64. Let us check now. Going approaches. It's running now. The iteration is going on. It will go 100 iterations. Once the approach has been completed, we will see our performance matrices. I think it's done. Let us check its performance matrices. What is our R square and mean square? So here the complexity is very less. So as per your problem, you can yeah. Now little bit changed. So 0.05 it come to R square is 0.71. So like that you can update your results. So previously our prediction is something different. Now it's come closer to this. So that's why we got a different outcome. Now we look at it like how the overfitting underfitting is there by plotting training and testing plot. Is done. Yes, it is done. So same we can calculate our future prediction based on your which parameter influential you want to check. You can give a future prediction value. You can predict. Suppose I told Prandtl number is not working more than if you go 100 or 150. So based on the problem complexity. See here, our data is good fit only because our training and testing examples are very similar, very nearer. But only thing is that we have to change the hypertuning parameter. The only thing is that we will change, we will get a better result. And this also very simple neural network. It's not much complex. If you go artificial neural network or if you go convolutional neural network, it will be more good one because the problem complexity is totally different. So here the same Prandtl number 0.72. We got this 1.7. I choose the same 100. Let us check. Or if you go to fluid case, the prediction is changing, right? So as per your problem, you can choose it. What will be convenient. Thank you.
Thank you, Dr. Sir. It's a very wonderful presentation. Good afternoon, everyone, once again. Respected dignitaries, faculty members, and dear students. Uh, it was an eventful day with fruitful expert talks, workshop, and discussions. I would like to take an opportunity to thank each and everyone involved in this, even you could say, very fruitful events. It's my privilege to propose vote of thanks on this special day. We are indeed honored today to have with us Dr. Varun Kumar, Professor and Associate Dean, Lovely Professional University, India, and Dr. Tamim Bhasha, Department of Mechanical Science, Ulsan National Institute of Science and Technology, South Korea, as a keynote speakers. In present times, gaining our knowledge is incomplete without hands-on and you could say hands-on and experience using the technology. Dr. Varun Kumar has given us the workshop based on the university data sets, how we can solve the admission related queries. Dr. Tamim Bhasha has given us insightful on the fluid flow modeling and predictions model, how the things are going on as far as the data is going from data is being moving in one particular mesh. Uh, Using the machine learning and predictions of fluid flow problems. On the behalf of MAHE Dubai campus, I would like to thank Dr. Varun and Dr. Tamim for taking out time of their busy schedules and being with us to share their valuable knowledge. On the behalf of organizing community, I would like to convey our deep regards to hearty thanks to Dr. Sudhindra Samanna, Academic President, for his valuable supports throughout the event. A special thanks to our respected Dean, Dr. S.K. Pandey, and Deputy Chairperson, Dr. Rajiv Salvan, for their constant supports and guidance, which has been instrumental in this symposium. Uh, Thank you, participants, our future researchers and engineers from MAHE Dubai and international universities for your participations in this forum. I would like to thank all the program directors, coordinators of School of Engineering and IT for their timely advice and guidance. My special thanks to Dr. Javed for technical guidance and supports, department faculties. Words are not enough to thank their constant guidance and support to shape this symposium. This event, which has virtual component, would not be possible without the seamless technical support. And a great thanks to Mr. Shekhar, Ms. Anjuma, Mr. Subani, Mr. Khalid, Mr. Ali, and all the staff from the facility departments. Finally, a big thanks to all the students, volunteers from School of Engineering and IT for the smooth conductions for this symposium. Thank you very much.